What's up, 20-1? Hopefully you guys are all doing good out there and keeping busy. So this is lesson 4 on solving rational equations. Before we were looking at simplifying rational expressions, looking at adding, subtracting, multiplying, dividing them, and determining their non-permissible values. Now we're gonna go try and solve. So we're really looking for where do these two rational expressions cross or intersect. And so I wrote out some steps there that you can always follow to help you solve here. So it says factor all denominators, and really I would just factor everything. And then find a common denominator. And the purpose of finding a common denominator is so in the next step, we can multiply both sides of the equation by the denominator, which essentially just completely gets rid of the denominator, and then we can solve for the numerator as we usually would. The last step, which is common to what we've kind of been looking at in previous units, is you need to check for extraneous roots. So you either need to check by verifying and substituting that point into your equation to make sure it works, or ensure that that point is not a non-permissible value. So let's go employ these steps to a few questions. There is quite a few examples in the notes. I'm probably only going to go through maybe 4 in total here. So let's take a look at 1a. So I'm not sure how big that is for you, but it says x over 2 plus 3 equals 2 plus 3x over 4. And so the first step up here says find a common denominator. Well, these can all be written as fractions over 1. So what's the common denominator or the lowest common multiple between 1, 2, and 4? Well, the lowest common multiple is just going to be 4. So I'm going to need to take each of these terms and multiply by whatever it may be to get the lowest common multiple. So I would take this fraction and times it by 2. So here I'd be left with 2x over 4. I need to take this fraction and times it by 4. And remember, that gets applied to both the numerator and the denominator. So this is plus 12 over 4 equals, I also need to take this and times it by 4, so my denominator would be 4. So 8 over 4 plus this last fraction already has the common denominator that we're looking for, 3x over 4. So I kind of have 2 options here of how I want to solve next. If you want to combine it and put it all over a common denominator, that's fine. You want to get everything to one side, that also works. What I usually like to do at this stage is once I have a common denominator, what you're doing is I'm going to take this side, times it by 4, take this side and times it by 4. And doing that just cancels those denominators out. So I usually just say, ignore the denominator once it's common, and now I'm left with this equation. 2x plus 12 equals x plus 3x. Okay, so I'm multiplying by whatever the denominator is, which cancels it out on both or all sides, right? So now I just need to solve for my variable as I would, regularly algebraically. So here I'm going to subtract 2x and minus 2x, and I'm going to move the 8 to the other side. So I'll subtract 8. And so on the left-hand side here, I'm left with 4. 12 minus 8 is 4. And 3x minus 2x is just x. So x is equal to 4. Now, before I say, I'm sure that's my final answer, I should always check this. I can either put 4 back into here and check that the left side equals the right side. So if we want to do a quick check, I could say, okay, 4 over 2 plus 3, which is 2 plus 3 is 5, right? Because this is 2 essentially. Then we'll check that it equals the other side. So that would equal 2 plus 3 times 4 over 4. So this is 12 over 4, which this whole thing would equal to 3. So 2 plus 3 is 5. So that works. I could do that if I want to check for sure. Really, the big thing that I want to make sure that you do is check that your answer is not one of your non-permissible values. This graph actually has no non-permissible values because there is no denominator in that, or a variable in the denominator of that function. So this would not fall, at least in an extraneous root range. Let's go take a look at another one. C and B, or B and C, I guess, will be, you can check on the note package. I'm going to skip ahead to D. So 5 over 2y plus 11 over 12 equals 2 over 3y. So I need to take all of these terms and go find the lowest common multiple. So between 2, 12, and 3, they can all multiply to 12. And we only need to get them all to be 1y, so 12y. So now I'll take each term and multiply by whatever number I need to get all of their denominators to be the same. So I'll take this and times it by 6, and that needs to go to both the numerator and denominator. So this would be going to be 30 over 12y, plus, I just need to take this and times it by y. So to the top and bottom, that would just be 11y over 12y, equals, I need to take this fraction and times it by 4 to get the denominator to be 12y. So 2 times 4 is 8 over 12y. Now that I have a common denominator, to get rid of it, I would technically, mathematically, just be timesing everything by 12y, which gets rid of it. So once I see that I'm solving and I have a common denominator, I just cancel it out. Because technically I should times this by 12y to both sides, which ends up canceling all my denominators out. So I just focus now on my numerator once I have that common denominator, as long as I'm solving, right? This isn't going to work if you don't have an equal sign. You have to have something that you can solve for. Okay, so then I'll just solve for my remaining variable of y. So I will move the 30 to the other side, so subtract 30 from either side because it's an equality. So 11y equals 8 minus 30 is a negative 22. And to get y by itself, my last step would be to divide by 11. So y equals negative 2. So that's my answer. I do need to check that that is at least not a non-permissible value. So my non-permissible value here from my denominator that I canceled out here, just one of those terms. So 12y cannot equal 0. So y cannot equal 0. So this answer should be okay, assuming my mathematics is correct, because it at least isn't part of an extraneous root. It's not part of my restrictions. If I wanted to check for sure that that was the correct answer, I'd have to substitute that back in. Or I could graph the left side and right side to see that those points intersected at y equals 2, or actually the x equals 2. Okay, so that's some basic examples. Now I'm going to go look at some examples where the denominators are not just simple monomials. They are going to be, multiple binomials or monomials multiplied together. Which one do I want to take a look at? Okay, let's take a look at E, I guess the easier start. So E is 4 over 2x minus 1 equals 1 over x minus 2. So again, to solve, we should factor. These are pretty simple fractions, so I don't really need to factor those. I do need to find my lowest common multiple. So my lowest common multiple is actually just going to be a combination of those two binomials. It's going to be x minus 2, 2x minus 1. So that means I'll have to take this binomial and multiply it by x minus 2, and take this binomial and multiply it by 2x minus 1. So on my numerator, it would be 4x minus 2 over x minus 2, 2x minus 1, equals 1 times, which I don't really need to include, 2x minus 1 over x minus 2, 2x minus 1. So what I would do here is put, I have a common denominator, so I technically am timesing by x minus 2, 2x minus 1 to either side, which would cancel out the denominator, and I can just solve for the numerator. I'm going to multiply that out here. So this would be 4x minus 8 is equal to 2x minus 1. And now I just need to solve algebraically. So I'm going to move my 2x to the left side and add 8. So I have 2x is equal to 7. And my final step to get x by itself would be to divide by 2 on either side. So x is equal to 7 over 2, which is like 3.5. Okay. I would always want to check my answer and at least check that that's not one of my non-permissible values. My non-permissible values come from the denominator that I canceled out. So from here, x cannot equal 2, and x cannot equal a positive 1/2. that does not fall at least in my non-permissible values. So assuming that all my other work is right, that should be correct. If not, you can always go verify graphically, right? To verify graphically, I make this y1, make this y2, and go solve, and the x value where they intersect should be that value. Okay. The other way is to take 3.5 and put it back into x and check that the left side equals the right side for that point. Okay. Which one do I want to do? I want to do one more just to drive that home. Let's go for F. Just a bit more complicated. So here's F. I'm not going to read that out. You can see what it is. So the first step we said we should do here is to get a, or at least factor, right? We're looking for a common denominator, but before we can do that, let's factor. So 3 over that trinomial can be factored with a is equal to 1. So I'm looking for two numbers that multiply to -2 but add to -1. So that would be x minus 2, x plus 1, plus 4 over this denominator, which can be factored using a difference of squares. So x plus 2, x minus 2 equals 1 over this second last denominator, which can also be factored with a is equal to 1 trinomial. So I'm looking for two numbers that multiply to 2 and add to 3. So x plus 2, x plus 1. So now I got to go compare all of my denominators and see what could be what's going to be my common denominator out of everything here. Did I miss something? No, I'm good. Okay. So I have an x minus 2, I have an x plus 1, x plus 2. So it looks like my LCM, just going to write that over here, is going to be x minus 2, x plus 2, and x plus 1. So the first fraction, I'm going to have to take this guy and multiply it. I'm missing times this by x plus 2. So on the numerator, it would be 3 times x plus 2 over x minus 2, x plus 2, x plus 1, plus 4 over. Now this guy, to get to this lowest common multiple, is missing the x plus 1. So I got to times this entire fraction by x plus 1. So I times this by x plus 1. And the denominator should all be the same. Equals, this guy is missing x minus 2. So I have to take this and times it by x minus 2. So 1 times x minus 2 is just x minus 2 on the top. And my denominator is my lowest common multiple that I'm trying to get to. Okay? Once my denominators are all the same, just cancel them out. Mathematically, I should be multiplying by all of them, but that's essentially kind of what happens. Take a shortcut there. So now I can just solve for what's left on my numerator. So before I write my next line, I'm also just going to multiply. So 3 times x is 3x. 3 times 2 is plus 6. 4 times x is plus 4x. 4 times 1 is 4, which equals x minus 2. And so I'll solve by combining like terms here, first of all. So 4 plus 3x is 7x, and 6 plus 4 is 10, equals x minus 2. I'm going to subtract x, subtract x. So I have 6x, and then I'm going to move my 10. So on the left side, the right side, I have minus 12. And then the last step to solve would just be to divide by 6 on either side. So x is equal to minus 2. Okay, so that's my answer. Now what I would need to do is go check that with my non-permissible values. Okay, so my non-permissible values come from this, denominator, common denominator that I canceled out. So x cannot equal a plus 2, a minus 2, or a minus 1. So now I'm running into this point where actually there's going to be a non-permissible value, which we'll look at in a bit. Could be a point of discontinuity or a vertical asymptote. So this actually cannot be the answer. So there would be no solution for this one. And if you graph that, and if you graph the left side and the right side, you'd be able to see that those graphs don't actually intersect. Okay. So that's why it's important to go check those non-permissible values. So hopefully that gives you enough to be confident to go try some practice questions and then complete the quiz when you're ready. So thanks for listening. Have a good one.